During 1819-20, Ørsted, the scientist from Denmark, discovered that when a magnetic needle is placed near the wire carrying the current, it is deflected and sets itself in the direction perpendicular to the wire. On reversing the direction of the electric current, the needle set itself in the opposite direction. If the current does not flow in the wire, the needle sets itself in the geographical north-south direction due to the Earth's magnetism. From this experiment and several other experiments, it is established that electric current or the moving charge can only produce the magnetic field. If a particle with charge q passing with velocity vector v near any point at a given time in the magnetic field experiences the magnetic force vector F, then the magnetic field vector B developed at that point and instant is such a vector function which obeys the following equation. Vector F is equal to Q is vector V cross vector B. The direction of force vector F appearing in the equation vector F is equal to Q into vector V into vector B. Can be determined with the use of the rule of the right-hand screw. It is clear that this force acts in the direction perpendicular to both the velocity vector v and the field vector b. If a particle with charges q is moving in the direction making an angle theta with the magnetic field vector b, that is, if the angle between the velocity vector v of the charged particle and the field vector b is theta, then F is equal to Q into VB into sine theta. Therefore, B is equal to F upon QV sine theta. We can determine the units of the magnetic field vector B from equation B is equal to F upon QV sine theta. Unit of vector B is equal to F Newton upon Q Coulomb into V meter per second. That is equal to Newton upon Coulomb meter per second, because Coulomb upon second is equal to ampere. That is equal to Newton upon ampere meter. This unit is called Tesla T in SI. Therefore, Tesla is equal to Newton upon ampere meter. If a positive charge of 1 coulomb moving with a velocity of 1 meter per second in the direction perpendicular to the magnetic field experiences the force of 1 Newton at any point in the field, the field at that unit point is called 1 Tesla. The right-hand rule is used to determine the shape of the lines of the magnetic field produced due to the straight conductor wire carrying the electric current. Hold the conducting wire carrying the electric current with the right hand in such a way that the thumb remains in the direction of the conventional current. The lines of the magnetic field will be directed towards a circular path around the wire in the same way as the fingers envelop the wire. The lines of the magnetic field constitute the closed loops as shown in figure. He2 plus ion moves with velocity 10 raised to 5 meter per second in the magnetic field of 0.80 Tesla in a direction perpendicular to the field. Theta is equal to 90 degrees. Q is equal to 2 into 1.6 into 10 raised to minus 19 C. Find the force acting on this ion. F is equal to Q into VB into sine theta. 2 into 1.6 into 10 raised to minus 19 into 10 raised to 5 into 0.80 into sine 90 degrees. That is equal to 2.56 into 10 raised to minus 14